Because we're not able to meet because of the weather, I wanted to go through some of the material that I would have covered in class. Section 4 goes into another class of equations called rational equations. So in this video, I will talk about solving a rational equation that leads to a linear equation and a rational equation that leads to a quadratic equation. First of all, what is a rational equation? If you remember rational numbers, we've talked about those before. Something like the number 5/7, for instance, is a rational number because it is a quotient of two integers. Well, rational equation, hopefully that will denote to you that you're going to think about equations with fractional expressions. Specifically, a rational expression is a quotient of two polynomials, something like x minus 3 divided by x squared minus 4 is a rational expression. Notice that a rational expression will have a variable in the denominator. Because of that, we have to be very mindful of something that we call restrictions. Restrictions are values that make the denominator of a rational expression 0. Remember that if I divide some number by 0, I get that that expression is undefined. It's okay to have 0 divided by some number. That's simply 0. So we have to be careful about not including values that make the denominator 0 in our solution set. So our steps to solve a rational equation will be very similar to solving equations with fractions that we've done before. Our first goal was to clear the fractions from that equation, and we can do that by multiplying each side of the equation by the least common denominator. Before doing that, we may have to work with the equation to get it in a form so that we can identify what that least common denominator is. That would require us to factor any denominators. We can also, as part of this process, determine the restrictions that make the expression undefined, find out what the least common denominator is, multiply each side of the equation by that LCD, solve the resulting equation, which in this section will either be a linear equation or a quadratic equation. Remember, quadratic just means that it has an exponent of 2 on the variable. And then we're going to throw out any extraneous solutions. So extraneous solutions are values that solve the equivalent equation, but not the original equation. When we alter the original form, we may get more solutions than we need. And so we have to make sure that the values we get work in that original equation. So let's look at some examples. The first example is 1 divided by 2 plus 7 divided by 2y equals 8 divided by y. The denominators are written in their simplified form. No factoring is needed. The restrictions on the variable come from what makes each denominator 0. So the 2 obviously can't be 0. 2y is equal to 0. When we divide each side by 2, we get y is equal to 0. And then the third denominator is y equals 0. So the restriction is that y cannot be 0. Now the least common denominator is the expression that all of those denominators divide into. So we need something for 2 divide into it, so we need a factor of 2. From the second denominator, we need a factor of 2 and a factor of y. We already have the 2, so we need a factor of y. And from the third denominator, we need a factor of y, which we have. So 2y is the smallest expression that each of these denominators divide into. Then we multiply each side of that equation by that LCD. And that really just means we multiply each term of that equation by the LCD. Dividing out common factors, we just get 1y, or y, plus 7 is equal to 8 times 2, or 16. Subtracting 7 from each side gives us that y is equal to 9. 9 is not a restriction, so we can write that in a solution set, showing that it is the value that makes the equation true. Our next equation is x divided by x plus 3 plus 3 divided by x plus 3 equals 3 divided by 4. The denominators can't be factored. The restrictions come from the denominators containing variables, so that x plus 3, when we set it equal to 0, we find that our restriction is negative 3. So we cannot have a negative 3 as a solution. Our least common denominator includes factors that each denominator will divide into, so we need an x plus 3 in our LCD. We already have the x plus 3, so then we need a 4. So 4 times x plus 3. Now we multiply each side, or again each term, by that LCD. In so doing, we're left with x times 4, or 4x. In the middle term, 3 times 4 is plus 12. And on the right side, the 4's divide out. Now we distribute 3 to get 3x plus 9. So this is a linear equation. We solve it by isolating the variable to one side by subtracting 3x. And that gives us x plus 12 equals 9. And then we can subtract 12 to get x is negative 3. But remember what we said, that x can't be negative 3 because it makes the denominator 0. Now negative 3 is the solution of this altered equation, which is an equivalent equation, but it's not a solution of the original equation because it makes us divide by 0. So this is an extraneous solution, which we must discard or throw out. So that means our only solution is nothing. So there's no solution to that equation. So we would write that as the empty set. Now, the next objective is very similar. The only difference is that the resulting equation will be a quadratic equation. We can solve a quadratic equation by factoring the quadratic formula, completing the square root property, but most of these are going to factor for you. So looking at it, it doesn't look any different. We have 4 divided by x minus 4 minus 6x divided by x plus 4 equals 6 divided by x plus 4. The denominators can't be factored, so we find our restrictions, which come from setting each denominator equal to 0. X minus 4 is equal to 0 when x is equal to 4. And then x plus 4 is equal to 0 when x is equal to negative 4. So our restrictions are that x cannot be plus or minus 4. For the least common denominator, we need the factor of x minus 4 to divide into it. And then we also need this factor of x plus 4 to divide into it. And the last denominator we already have included. So now we multiply each of these terms by that LCD. and divide out the common factor of x minus 4 in the first term. Be careful to distribute, so that gives us 4x plus 16 minus, in the middle term, notice that the x plus 4 cancels, and now we distribute a negative 6x. Very important there. So that's going to make that a negative 6x squared plus 24x, right, when we distribute a negative to a negative, and that's equal to 6x minus 24. Notice that this is a quadratic equation because of the square. So we need to set one side equal to 0 and try to factor. Let's first combine like terms, so we get negative 6x squared plus 28x plus 16 is equal to 6x minus 24. We can subtract 6x and add 24 to each side. And that gives us negative 6x squared plus 22x plus 40 equals 0. I would notice here that there is a common factor. There's a common factor of a negative 2. Right, if the first sign is negative, divide by a negative. And that's going to give us the equation 3x squared minus 11x minus 20 is equal to 0. And so we can factor this. The factors of 3x squared are 3x and x. The factors of 20, there's 1 and 20, 2 and 10, 4 and 5. And I'm going to go ahead and show you that this would be a 4 and 5 because the outer needs to be 15 and the inner needs to be 4 to get the 11. Remember that we could do 3 times the negative 20 is negative 60. Look at the factors of 60. You don't even need to worry about the negative sign there. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 6 and 5, 5 and 12, and 6 and 10. The 4 and 15 are what you would need to use to do the AC method. So we need a negative sign on the larger. 3 times 5 is 15. That's larger than 4 times x. So we have 3x plus 4 times x minus 5 equals 0. So we get that 3x plus 4 is equal to 0, or x minus 5 is equal to 0. So 3x is equal to negative 4. X is negative 4/3, or x is equal to 5. And neither one of those are restrictions, so our solution set negative 4/3, 5.